Hi, everybody. My name is Laurie. I am a little bit too loud. I am VP of Developer Relations at LlamaIndex. In a former life, I co-founded NPM Inc. So some of you may know me from when I used to talk incessantly about JavaScript. Now I talk incessantly about AI, but either way, I talk incessantly. Today, I'm going to quickly introduce you to LlamaIndex. I'm going to talk about what it is, why you should use it and what it can do for you, including retrieval-augmented generation, world-class document parsing, structured data extraction, and autonomous agents. So what is LlamaIndex? It is a bunch of things. Start with the most obvious. We are a framework in both Python and TypeScript for building generative AI applications. The Python framework is older and bigger. The TypeScript framework is growing very fast. Both are obviously open source and free to use. But that is not all we do. A service that you may be interested in is LlamaParse. It is a service that will parse complicated document formats in any format, PDF, Word, PowerPoint, a dizzying list of file extensions, into text or Markdown to be understood by LLMs. It turns out that LLMs are much better at getting results about the questions you ask them when they can sort of pre-digest the data in your complex document formats into a simpler text-based format that they can understand. Another thing that we do is Llama Cloud. LlamaParse is part of Llama Cloud. If what you want to do is take all of your complicated documents and stuff them into one end and get world-class retrieval out the other without having to bother about all of the stuff in the middle, like scaling it and security and best-in-class retrieval, then that is what Llama Cloud is for. For the purposes of this conversation, you can get it for free, although generally it's going to cost some money. And there's Llama Hub, which is our registry of helper software. If you need to connect to any database in the world, we've got you. If you need to get data out of Notion or Slack or Salesforce, no problem. If you need to store your data in a vector store, we connect to every vector store that exists. You need to connect your data to an LLM, we connect to every LLM that exists. We support over 30 different LLMs, including local ones like Llama 3.2. If you want to build an agent, we've got pre-built agent tools that you can just import into your application. It is a huge it's a huge mine of really valuable software for building generative AI applications. But why should you use LlamaIndex? Because, frankly, we will help you go faster. You are developers, you have limited time, you're trying to solve novel problems. You don't want to get stuck on the boring problems. Don't get stuck figuring out the basics. We've figured out a bunch of the foundational problems for you. We will get you the best practices really fast, and you can focus on solving the novel and interesting parts of your application that are unique to your application. So enough of the sales pitch. Let's talk about what this framework can actually do for you. One of the biggest things that we do is RAG, which stands for Retrieval-Augmented Generation. Hands up if you already feel like you know what RAG is. All right, pretty good. All right, then I will just go through it at lightning speed. Retrieval-augmented generation is a response to a fundamental limitation of LLMs, which is that they have a limited context window. You can't give them all of your data at once for them to be able to answer questions about your data. You have to be selective, which means that you have to figure out how to select your data, which means that you have to use semantic search. This is a schematic, but again, you have mostly all said that you know what RAG is. You use a technology related to LLMs called an embedding model, and you convert your data into arrays of numbers called vectors. The total set of available vectors is called vector space. So this conversion of text into numbers is known as embedding your data into vector space. And so the resulting numbers are called embeddings. I don't know why we decided that 4 degrees of separation was how we would pick the name for that thing, but we call them embeddings. When you want to answer a query, you take the text of your query and you convert it into numbers in the same way. And then in vector space, your query and the answer to your query end up mathematically nearby to each other in this multidimensional vector space, which is the coolest thing that actually works. So that is the theory of RAG. Let's talk about how you build a RAG pipeline in practice. You ingest your data, you parse it into chunks, you embed those chunks, and you store them in a vector store. You then use your query to perform semantic search on the chunks in your vector store to get the most relevant pieces of your data. You take those pieces of your data and your query and you feed them to an LLM and you say, give me an answer to my query. Let's look at how you put those steps together in an actual LlamaIndex application. First, you need to get your data from somewhere, whether it's your file system or a database or an API. Like I said, our connectors on Llama Hub will do all of that for you. And it will turn all of your documents into compatible, identical document objects that you don't have to worry about making them all interoperable. The next step is parsing. We have a bunch of built-in parsers, but like I said, the real secret weapon here is Llama Parse, which can convert basically any document format into markdown or text that LLMs find very easy to digest and understand. Next, you have to embed your data. So you can use third-party APIs like OpenAI to do that, or you can use local embedding models like I'm using here. And like most of the things I'm showing you in this example, it's a simple one-liner in the framework. Once your data is embedded, you have to store it in a vector database. Like I said, we integrate with every vector database that exists. So again, it's a one-liner. And you don't need to learn about all of the different APIs, about all of the different vector databases. You can just mix and match them and swap them in as you need. To use your embedded data, you need to query it. So LlamaIndex will take care of that for you. It will embed your query, it will find the relevant chunks in your vector store, and it will return those chunks. It will feed those chunks and your query to the LLM and get a response. You do all sorts of stuff with the thing that is retrieving your data. You can customize it, you can add a re-ranker, you can do all sorts of things. And then we give you a query engine, which lets you do the final thing, which is like ask a question and get your response. And we don't just do all this stuff for text, we do all of this stuff in a multimodal way as well. So you can do this stuff for audio, you can do this stuff for images, you can do this stuff for video. Although for video, we're kind of cheap, we're just turning it into a series of pictures. If what you want to do is create a chatbot that chats to your data, which is what a whole bunch of people want to do. They want to create like a customer service API or something like that that knows about their documents, that knows about their company database, then you do not have to build it. We have turned into a one-liner. You just run npx create llama, and you will build you a full stack front-end and back-end application in your choice of Python or TypeScript that will give you a chatbot that can talk to your data wherever your data happens to be. Create Llama is an excellent way to get you 80% of the way towards solving your problem, and then you just customize the things that you want to change to suit your specific application. But the point of this talk, and the point of LlamaIndex in general, is that there is more to this problem than naive RAG and 5 lines of code. Naive RAG is limited. It tends to work for simple questions over small sets of documents, and there are a number of ways that naive RAG can fail. One task it's not great at is summarization. Like I said, the central feature of RAG is that you're doing search. You're taking a query and you're looking for specific chunks of your document that are relevant to that query, and you're sending them to the LLM. What if you want a summary of the entire document? That's not what RAG is designed to do. So it's not good at doing that. Another task that's tricky for a strictly search-based RAG pipeline is comparison. If you've got a bunch of data about different people, for instance, and you want to say compare person A to person B, your query is literally going to be compare person A and person B, and it's going to find chunks that are related to person A and person B, and then the LLM is going to try and compare them, but it's not necessarily going to know which chunk is about which person. It's going to get them confused unless those chunks are really, really accurately labeled. So that's another place that, again, just naive RAG can fail. More generally, naive RAG fails at multi-part questions. If you ask your pipeline to summarize the arguments of article A and compare them to the arguments of article B and put them in a table to compare them, it's going to get very confused trying to do all of that in a single shot. Which isn't to say that naive RAG is useless. Naive RAG is an extremely powerful tool. It's kind of magical. So it's necessary but not sufficient. Lots of tasks require semantic search, but lots of tasks require you to go beyond semantic search to be able to solve your problem. So how do we go beyond the limits of RAG and fully utilize the power of LLMs? There's two avenues of improvement that we can follow here. The first is to improve the data quality, and the second is, and that's one of the reasons that we built LlamaBars, is just to improve the quality of the data that goes to the LLM. And the second way is to make your querying itself more sophisticated. We're mostly going to be focusing on the second one today. And the way that we're going to be improving our querying is by using agentic strategies. Agents is a term that in this industry that is overused to the point of being almost useless. So when I use it, what I mean is semi-autonomous software where you can give it a goal and it can use tools to solve that problem for you. The key thing there is that you don't, unlike normal programming, you don't know when you give an agent a goal to solve your problem, how exactly it's going to solve that problem. You've just given it a goal and it's going to use the tools available to try and figure it out. Let's talk about agentic strategies and how we can build them up into a full-fledged agent. So a naive RAG pipeline, like I said, has a bunch of limitations. It's single shot. You just get one question and one response. There's no query understanding. It's just semantic search against the text of the query, and that's all that it does. There's no tool use, so you can't go out and seek more information. And there's no reflection or error correction. The pipeline does not know whether or not it adequately answered the question. It gives you the answer and says, here you go. And finally, there's no memory. Every question is brand new. It doesn't know what you previously asked. It has no context. You can fix all of those things by building agentic RAG. You can make your queries multi-turn. You can have the agent understand the question that's being given and plan how to get the answer in multiple steps. You can make RAG just one of many tools allowing your agent to interface with the wider world. And it can get other sources of data and it can take action in response to what you asked it to do. You can use reflection to figure out if the response that your LLM has given is adequate, and if not, it can course correct, it can replan, it can ask the question in a different way. And of course, you can have memory so that your questions become part of a larger context of what has been asked before and how to get to your answer. Getting all of that done is a lot of work, but it's a lot of work that LlamaIndex has done for you. So with most of this stuff, you can do it in just a couple of lines of code. The strategies that I'm talking about here exist on a spectrum of complexity. Some are very simple to implement and thus very cheap to implement in terms of the number of tokens that you're going to use and how many API calls you're going to use. And as you go along, they get more complicated. They get more powerful, but they also begin to take more time and they begin to take more tokens. So it's not just a slam dunk to immediately go over every problem, just like, let's just build the most complicated agent we can possibly get, because that's not necessarily what you're going to want to do. Let's break down the strategies one by one. The first up is routing. This is the simplest form of agentic reasoning. Given a query and a set of basic tools, the router uses the LLM to select which of the tools is going to best answer the question. This can solve, for instance, the summarization problem. You give it two tools, and one of them knows about one of them knows how to do RAG, one of them knows how to do semantic search, and one of them has a full document summary. And the LLM can decide, based on what the question says, whether or not it is going to provide you with semantic search or it's going to provide you with the full document summary that you asked for. This is built into LlamaIndex. It's the router query engine. This is an abbreviated version of an example of that in action. You can see us creating two tools. Like I said, one is the regular RAG query engine, and one is a full document summary. This solves the routing problem, but it's still one shot, so we can do better than that. The next tool that we can add is memory. This is theoretically simple. As you run queries, you include them in your history. So every time the LLM gets a new question, it compares to the history and it sees what you've previously asked and it gets this better context. There's some complexity there. As your history begins to get very long, it begins to overflow the context window. So you have to take older history and begin to condense it down to just the relevant points. But we take care of all of that for you. Again, history is a built-in in LlamaIndex. This is almost identical to the 5-line starter, except instead of a query engine, we create a chat engine, and we chat instead of running queries. All the memory stuff is handled under the hood for you. Yes, this meeting is being recorded. Is that in there the whole time? Great. Then we can add one-shot query planning. What this does is it takes a complex question and it breaks it up into simpler questions, each of which can be run in parallel without conflicting with each other. You can then take the resulting responses and get the LLM to aggregate them into a single adequate response based on far more context than trying to do it all at once. This is a really great way of handling the ability to do comparisons. The built-in here is called the sub-question query engine. We can create as many RAG query engines as we need. We can give them metadata that's describing what each one of them does. And we can provide an array of them to the sub-question query engine, which will execute as many queries in parallel as it needs to be able to answer the question and then combine the answers. The router query engine and the sub-question query engine are both examples of the biggest part of making agents and agentic RAG effective, which is tool use. You can describe an arbitrary API to an LLM, and it can figure out how to call that API and use any piece of random code as a tool. It is a spooky result of fancy autocomplete LLMs. We're not supposed to be able to figure out how to do tool use, but they can do tool use, and it's extremely useful. So we keep asking them to do it. Tool use doesn't just pass the query; it adapts the query to the tool. So for instance, in auto retrieval, it takes the query and uses it to decide how to pre-filter data by using keywords in the metadata to filter it down. If you are asking a question of a SQL database, your tool can convert your question from natural language into SQL and then run SQL to query the database. Or if you want to take an action, for instance, you want to make a calendar invite, you can give it the API to a calendar application and it will create an event for you as a result of what you asked it to do. You've already seen in the examples that I put on the screen some examples of tool use in LlamaIndex. In the router query engine and the sub-question query engine, those both use RAG engines as tools, but you can use any arbitrary piece of Python code as the tool. In fact, you can do tool use in JavaScript as well, so JavaScript code will also work fine. You can use as many of these tools as you want, and you can use query engines and functions at the same time, so you can really get incredibly powerful pieces of software just by giving as many tools as you want to an LLM. So now we've seen the basic agentic strategies, but they are just the minimum necessary to put together a full-fledged agent. We need to go further. We need to make it multi-turn. We need to give it reasoning and planning. Let's give it reflection, and let's talk about how we get all of those things done. There's three types of agentic reasoning loops that I want to talk about today. One is sequential, one is DAG-based, and one is tree-based. Unlike the other agentic strategies, these live on a spectrum of complexity. So you're not necessarily going to go all the way straight to language agent research, which we're going to talk about. You're going to want to make trade-offs about like how many tokens, how much time, how much expense do I want to put towards solving this particular problem. So the first type of reasoning, well, it doesn't work if you turn your head from the mic if the mic's attached to your face. The first type of reasoning is sequential. In this one, you generate your first steps given your previous steps. So this is sometimes known as chain of thought. One of the most popular patterns here is called React, not React the web framework, but reasoning and action. We already saw it when I demonstrated tool use. In React, the LLM generates a distinctive pattern where it makes an observation, it decides what to do, and then it takes an action based on that observation. And it stays in a loop of doing that observation, thought, and then action over and over until it has solved the problem or it gives up. You can see this in action in the output of a React agent shown here. It creates a thought about what it should do next. It selects one of its available tools as an action. In this case, I gave it an add and a multiply tool, so it's picking which one of those to do a math equation. And then it has an observation, which is the output of using that tool. And it keeps going until it doesn't need any more tools to answer the question. This is the basic agent loop. The next step up in terms of sophistication is the DAG-based planning agent. To back up for a second, a DAG is a directed acyclic graph, which is a fancy computer sciencey way of saying something like a flowchart, a bunch of boxes with arrows between them going from your beginning to your end. In DAG-based planning, the LLM comes up with a full plan from start to finish about how it's going to solve this problem, something like a flowchart. A critical part of this planning is the ability to replan when things don't work out. So every few steps of actions that it's taken, it can look at the output and say, is this the output that I was expecting? Am I actually solving the problem, or do I need to come up with another plan to try and get there? This ability to self-evaluate is called self-reflection. The LLM is smart enough to tell whether the LLM is doing a good job, and that is another one of the sort of surprising results of using LLMs to be software. You can also get a human in the loop to tell the agent whether or not it's doing a good job. You can say, ask that human whether or not I've started solving this problem. Once again, doing this in LlamaIndex is simple. We've created two tools in advance here: RAG pipelines that have financial documents about Lyft and Uber in 2021. We provide these to a function calling worker, which is what does the actual work. And then the worker plus the metadata about those tools goes to the structured planner agent, which creates a DAG-like plan. And here's the first step of that output. What you're seeing is three pieces of output. The first two are parts of the plan to solve the answer. And the third is a step that requires the output of the first two. So you can imagine a very simple flowchart where it's basically got two lines in the box going to one thing. It's saying, okay, I need these two steps to successfully complete before I can do this third step. But DAG-based planning still works best when the task is sufficiently constrained that there's a clear route from the beginning to the end. And most tasks aren't like that. When you get to a more open-ended task, what you need is more like tree-based reasoning. There are several different variants to this, including tree of thought, reasoning via planning, and language agent tree search. But they have some fundamentals in common, which is that you don't know in advance how or whether they're going to be able to solve your problem. So instead of building a single plan from start to finish, what these algorithms do is they create sort of experiments. They came up with several different next steps for every step. And they build a tree of all of the possible worlds that could result with them taking these actions. They explore further down the tree to say, okay, I've taken this step, what other steps could I take? Out of those steps, what other steps could I take? And it creates this tree of possible alternatives. How do they know whether or not those alternatives are getting better? How do they know whether those alternatives are getting them closer to the goal? Well, again, you can ask a human to tell them, or you can create a function that tells them, or you get an LLM to tell them whether or not these steps look like they are getting closer to the goal than they did before. What the agent does is it will explore these possibilities, and then it will find the one that looks best, and it will throw away the branches that weren't working, and it will continue down the successful path. This balance between exploring possibilities and extending down the tree is called the balance between exploitation and exploration. One of these strategies is implemented in LlamaIndex as language agent tree search, or LATS. As we did with the structured planning, we create a worker from a set of available tools. The expansion parameter controls how many new branches at every level the agent will create. and the rollouts parameter controls how far down the tree the agent will go before it decides that it has, to pick a branch. So now we are pretty deep into LlamaIndex. We can build a RAG pipeline, we can build agents that use RAG pipelines. The last thing we're going to cover today is workflows. Workflows allow you to build upon those patterns and create more complex LLM applications. Specifically, it allows you to create multi-agent systems where the agents that we've been building so far can work in combination with each other to achieve more complex tasks. Why do we need this extra feature of the framework? We are responding to the evolution of the space. We have discovered, and our customers have discovered, and our users have discovered, that as your agents become more complicated, as your application becomes more complicated, reasoning about it and managing state within a complex application becomes extremely difficult. And so this abstraction exists to be able to manage that complexity and make it easier to understand. The most basic workflow looks like this. A workflow is composed of steps. And you can have as many of them as you want. You create a class that holds all of your steps, and steps are marked with a decorator. And they use type descriptions to specify which events should trigger them and which events they emit. So in this most basic example, I've created a function called generate and marked it as a step. It accepts a start event and it emits a stop event. So this flow just has, one step. Okay, cool. One of the most important things that you can do with workflows that you can't do with graph-based attempts to solve this problem is loops. In this simplified example, you can see how this works. We now have two steps. The first being steps the start event, and it tries to answer the question. In this case, anything random numbers to simulate whether or not it successfully answered the question. If it gets a bad answer, it emits a failed event, and this triggers the improved query step, which will try to come up with a better query and emit a query event, which gets picked up by the answer query again. If it answers the query correctly, it emits a stop event. If it can't improve the query, it also emits a stop event. All the possible flows in this workflow are visualized in this diagram, and this diagram visualization is a built-in feature of the framework. You can just call that one line of code, and it will generate this nice interactive graph of all of your flows, and this is extremely useful for debugging and visualizing what it is that you built. In addition to passing events around, there's also a global state that all of your steps share. Called the context. This is great for your initial ingestion step when you can create your indexes and make them available to all of your steps. You can see here that we're calling single directory reader just like we did in the 5-line starter and assigning it to a variable called index. So while these examples are all very simple, necessarily to be able to fit on the slide, keep in mind that each of these steps can be arbitrarily complex. Each of the steps there could be its own agent in its own right, figuring out using any of the strategies that we talked about before. So you could put a sub-question equation in there, you could put a router query engine in there, you can do all sorts of things in each step and have multiple agents in multiple steps talking to each other, reflecting on the code that they're writing, helping each other out, and producing the final result. As workflows mature, we will be releasing pre-built workflows to help implement common design patterns. And with those in hand, you'll be able to customize them to meet your own specific needs. This is because all workflows are just classes. You can subclass them to create your own versions and extend existing workflows. I wanted to point you out we're very excited about workflows. The early feedback on them has been extremely good. People are finding them very useful. So I wanted to point you to some examples of some more complete existing workflows. The first is this multi-agent workflow, which is a template that you can launch with Create Llama, which I was telling you about earlier. What this does is it creates an API that generates a blog post. There's one agent that researches the blog post, there's one agent that writes the blog post, and there's a third agent that critiques the work of the other two, producing a system that can generate a really high-quality output through a very simple series of steps. The second one is a multi-agent concierge. Another very common use case that we run into is people trying to build customer support bots, and this is one of those. In this one, each agent is good at doing a specific thing for the customer. In this case, it's a financial concierge. So one of them is about checking your balance and all of the questions you could possibly have about checking your balance. One is about sending money to another person. One is about logging in the first place. And these agents can bounce back and forth between each other to solve whatever problem it is or whatever series of things the customer wants to get done. And the last one is the full stack application, front end and back end both written in Python using a framework called Reflex. This again provides a chatbot interface. It's a full agentic system for enhancing the queries to that chatbot. Like I said, if you're building a chatbot, we've already built one for you with Create Llama. We will just generate it for you. But this is an excellent way to get started and get you down that path. But the title of this talk, I said, is about multi-agent systems. And so far, we've got some multi-agent systems, but we haven't put them into production. Let's wrap up by getting them to production, because once you build a workflow, you have a system, we have a system that helps you deploy them. And it's called Llama Deploy, because everything that we invent is called Llama something. The basic idea of Llama Deploy is that we take each of these workflows that we've talked about and we turn them into a microservice that exists independently of each other. So each one of these microservices can be built and scaled independently of each other. And they have a backbone and message passing system that we take care of for you that allows you to launch them and scale them independently of each other. This is a really powerful pattern for getting these things into production. Deploying control plane is as simple as this. It's just a few lines of code. Deploying a workflow that you previously defined is similarly simple. They're all just microservices. You tell them to bind to an IP and then and a port, and then you're good to go. Where things get really interested is when we introduce nested workflows. Workflows can run other workflows. So you can split your multi-agent system into workflows and pass them into each other, and Llama Deploy will automatically spin up each one of these as an independent microservice. And each nested workflow will run everything on its own without any further interaction on your part. Llama Deploy is the newest feature of LlamaIndex, so we're eager to get feedback on it. So please head to the repo and tell us how this is working for you. We're very excited about it. So that's the end of the talk. We've covered a whole bunch of stuff today. We've introduced LlamaIndex and its sub-projects like Llama Cloud, Llama Hub, Create Llama. We talked about RAG, the stuff it can do, the stuff it can't do. We talked about specific reasoning agents. We covered workflows and we covered deploying them. What happens next is up to you. We are very excited about this very large tool set that we've put together for you. And we welcome feedback from the open source community, which means you. If you follow this QR code, you can go to our Discord and ask questions of our engineers, who spend far more time there than I'm comfortable with. And we also have extensive documentation that I personally spent a lot of time writing. So if you have any feedback about that, come straight to me. All of the slides that you've seen, all of the links that I've included on these slides are available at one place, which is at this QR code or at this link. So if you don't take a picture of anything else, you can just take a picture of this one and you'll get everything else. I hope this has been a useful introduction to you, to LlamaIndex and to the wider world of AI, generative AI applications. It's been a pleasure to speak to you, and thank you for your time and attention. Do you want to do questions?
Yes.
Okay.
Now, I'll run around with the microphone. By the way, we're recording. We'll share the recording towards the end of this week when it's up. So you don't need to take a picture of every slide or record yourself. We'll share out the recording afterwards, which you can record yourself if you want. Any questions? Yes.
Hey, can you share what you did for draft history? You said you condensed it
Yeah.
for personalization. Can you share what's some of those techniques?
That's a good question. We have a bunch of different strategies for condensing chat history that are built into the framework. The most obvious one is the condensed method, where you basically take what's been previously said and you ask the LLM, what are the important points of this? What part is just, people talking back and forth, and what part is like specific decisions that they made or questions that they answered, and you boil those down into text. The other thing that you can do is you can provide a RAG-based memory. So your question every query becomes a question to a RAG pipeline, which you feed your entire history into a RAG database, and every question becomes a query to that RAG database, which then fetches the most relevant context from your memory to try and beef up the answer to the question.
I see. And the first example you gave, do you embed the summary?
No, not usually. With the simple memory, we just keep the condensed version in the context that we answer the question with.
Okay, great. Thank you.
Cool.
Thanks for your talk. Can you give one good example of a nested workflow and one where you terribly failed?
One good example of where it works and one where it didn't work.
Yes.
So a good nested workflow is when we have differences in scale of what's going on. So if you have a whole bunch of simple questions that go to your main workflow, and you want to scale that up to dozens of listeners, and then you have one deeper workflow that answers a more complicated question which doesn't get triggered all the time, you would make that a nested workflow, and then you wouldn't have this expensive LLM lying around answering really complicated questions when you only needed to answer like one question in 10.
How do you define a complicated question?
You can get the LLM to do that. You can get the LLM to say, this is one of, this is a question I've seen before because you're using query hashing or something like that. Or this is a simple question that I believe I can answer in one question. Or you can get the LLM to say, this looks complicated. This looks like I need to split it into multiple questions and ask more questions.
Like LLM is a judge?
Yes, exactly.
Thank you.
I'm here.
Yeah.
Just a logistical question. The reflex framework you mentioned, can you mention the name of the actual framework?
I think it's just at reflex.dev. It's a really nice framework, actually. Our Python engineers really like it because it means that they don't need to learn JavaScript anymore.
Wonderful. Sounds good.
Yeah, you were talking about this model where you had three agents producing, one doing something and the other critiquing.
Correct.
So is it possible for the one that critiques to actually check whether the output is actually, is real as opposed to something that completely made up hallucination?
Yes, that is one of the really useful things that you can do with self-reflection is you can check for hallucination.
And how would you actually do a search on the web? Because you could, it's not just a matter of increasing the context, because it's also a matter of the LLM will create, scenarios that are plausible, but may not accord with physical reality.
Right.
So how would you actually have a critiquer, the critiquer agent to actually verify that these actually are in accordance with, laws of gravity or things like that?
One of the frustrating things about LLMs, there's no completely foolproof way to prevent them from hallucinating. But one of the things that there are a lot of strategies that you can do to get them closer to zero hallucination. And one of them is, terms for it vary, but we call it groundedness. Basically, you get the LLM that is judging the other ones to query the documents and see if it can find the original source document in your database that is the source of this claim. And if it's not, it says, okay, I don't know whether this is true or not, but it's not grounded in the facts that you were given. So go back and try again.
Okay. Thank you.
Any other queries?
I had one question. So,
Oh, sorry.
How does task planning work? So given a task, the LLM that breaks it down into the task, and does all the planning, or is there any deterministic input that the user can provide?
In the DAG-based planning, what we're talking about, and the LLM is coming up with a plan, it is generating all of the steps at once.
So is there any human input that can be given in the planning state, or is there any other input that can go into the planning state?
Absolutely. If you wanted to get human in the loop, you could absolutely say, okay, here's the plan that the LLM has generated. Do you think this is a good plan? Do you think that anything else needs to be done? Or you could get the human to prompt at the beginning of the process, come up with a plan. I think it's going to involve you doing this. And the LLM is totally capable of coming up with a plan based on that. Shall we do one last question over there?
I'm coming.
So I imagine for some applications, these tools may be accessing some personal information in some applications. So what are good strategies to make sure that privacy doesn't leak?
There is a whole body of research into protecting PII from this stuff. One strategy is to prevent PII going in the first place. So at the ingestion stage, you get an LLM to look at the data that's going in and filter out anything that looks like it's personal information and turn it into like a code word. So then on output, it says, okay, I have, here's your answer. Your answer will contain these code words, and you can decide whether or not, I'm okay with an address or a phone number or a credit card number coming back out in my output. And if not, it was never there. There are also LLMs that can, you just use LLMs as a judge to go, does it look like this is leaking personal information about somebody? All right. Thank you very much.
Thank you, Laurie.